Hi everyone, welcome to today's session on modern data stack. In this lecture, we will take a simple look at different parts of the modern data stack. You will learn what a typical modern data stack includes and why each part is important. And you will also understand the flow of data from ingestion to consumption across various layers and tools. This lecture is really important because it sets the foundation for the whole bootcamp. I suggest you watch it carefully, take your time to understand, and pause whenever needed to explore things properly. As we go further in this bootcamp, we will dive deeper into each component to help you understand how everything works together. All right, so let's get started. So, what is a modern data stack? If you look, like, it's basically a set of connected tools and technologies designed to handle, process, and make sense of large amounts of data. It covers everything from collecting and storing data to processing, analyzing, and visualizing it. Here is how it works. So, there is a data collection and storage. So, data is pulled from different sources and stored it into scalable systems like data lake. These systems can handle both structured and unstructured data. Data processing. Tools like Apache Spark or Apache Trino are used to clean and transform raw data into meaningful transformation. Analysis and visualization. Business intelligence tools, analytics platform, or even machine learning models are used to find patterns, make predictions, and create visual reports. Monitoring. To make sure everything runs smoothly, monitoring tools are used to track performance and fix any issues. So these modern data stacks often use cloud platforms like AWS, Azure, or Google Cloud because they provide flexibility and scalability. Since it's modular, organizations can pick and choose the tools they need and scale up as their data grows. This makes it a strong foundation for making data driven decisions in today's fast moving world of data engineering. So let's start with data source. We have already covered data sources in detail in the previous lecture. So I will not go into much detail here. Just to summarize here, data sources play a critical role in building a data lake because they serve as the primary entry points for raw data. These sources provide the real world data that drives analytics, reporting, and decision making within an organization. Production systems such as applications, databases, APIs, and streaming platforms generate data during regular operations. This raw data is ingested into the data lake in as is form without much transformation. Now, let's go to data pipeline orchestration. In the modern data stack, tools like Apache Airflow are essential for managing and automating data workflows. They help ensure data moves smoothly and reliably between different parts of the system. From pulling data in to transforming it and loading it where it's needed, these tools handle complex processes efficiently, making them a key part of any data setup. So, what are the key features of data pipeline orchestration? So, the key features and their importance are automation of data workflows. For example, every night, data from your production databases can be extracted, processed, and stored in your data lake without anyone pushing buttons. Dependency management. Tasks often depend on each other. Airflow uses DAGs, directed acyclic graphs, to ensure one task finishes before the next begins. For instance, you can ensure raw data is processed before loading into a report. Scalability. Airflow handles workflows of all sizes, from small batch jobs to large scale pipelines with terabytes of data. This flexibility makes it a perfect fit for growing businesses. All right, so let's move to data pipelines. So, data pipelines are the backbone of modern data stack. They are used to move data from one place to another, process it, and make it ready for analysis. So the purpose of data pipeline is to automate and streamline flow of data, ensuring it is clean, accurate, and available for reporting, dashboards, and decision making. Without data pipelines, handling data manually would be time consuming and prone to errors. Pipelines ensure data flows smoothly from its source to the storage and processing systems. So, why data pipelines matter? Well, mainly there are two types of data pipelines: data ingestion pipelines and data transformation pipelines. So, data ingestion pipelines focus on collecting raw data from various sources and bringing it into a centralized system like a data lake. And data transformation pipelines process the raw data collected in the ingestion stage, converting it into a usable format for analysis or reporting. This could include cleaning, filtering, aggregating, and enriching the data. Now, let's understand data processing engines. So, data processing engines like Spark, Athena play a critical role in handling analyzing large volumes of data efficiently. So, their purpose is to process and analyze raw data collected in a data lake, perform tasks like filtering, aggregating, transforming, or joining datasets, handle both batch historical data and real time, which is a streaming data processing. These engines are powerful, scalable, and designed to work with massive datasets, ensuring fast results even for complex queries. So, when these data processing engines are used, they're used in like batch processing, like for processing large data sets over a period of time, real time processing, like for streaming and analyzing data as it is generated. For example, like tracking live ride locations or payment statuses. Interactive querying, for running ad hoc queries to explore and extract insights from data. So we can use Athena or even Spark. Let's take a look at some of the popular data processing engines. So some of them are like Apache Spark, Apache Trino, Redshift, Apache Kafka, Apache Flink. And in this bootcamp, we will cover Apache Spark and Apache Trino. Now, let's move to data lake. So, a data lake is a centralized storage system designed to hold vast amounts of raw data in its original format, whether it is structured, semi structured, or unstructured, clean, and curated data. So, the main purposes are centralized storage and scalability, flexibility, and cost effectiveness. So the main purposes of data lake are centralized storage, like which is to store all types of data regardless of its format. Scalability, to handle massive volumes of data as it grows. Flexibility, to allow businesses to process and analyze data later based on their needs. Cost effectiveness, to provide a cost efficient way to store large data sets compared to traditional systems like MySQL or PostgreSQL. And this data lake acts as the foundation for modern analytics, enabling teams to extract insights and support data driven decision making. So, where data lakes are used? Mainly in three areas. Like one is data ingestion, like we collect data from multiple sources such as databases, OLTP systems, APIs, and logs and store it in the data lake. Data storage to hold vast amounts of data in its original form, and data analysis, which is like serving as the source for machine learning, advanced analytics, and reporting. Now, let's understand data serving layer. So, the data serving layer is the final step in data pipeline where the processed data is accessed and used for decision making, analysis, and other business activities. Its purpose is to take the cleaned, transformed, and structured data from previous layers like data lake. And in data lake, if you look at code layer or data mart layer, and make it available for analysis, reporting, machine learning, and other applications. This layer includes tools and systems that help users and automated processes interact with data to generate insights or take action. It ensures that data is presented in an easy to understand format and can be quickly consumed by different teams or applications. So, where is the data serving layer used? Mainly business intelligence, machine learning, custom analytics, experimentation. So for business intelligence, it is used to make data available for dashboards, reports, and visualizations. Machine learning to use data for training models and making predictions. Custom analytics, like as per different business requirements, we do need sometimes custom analytics. So this data can be used for custom analytics. Experimentation. For experimentation, like we can use it for analyzing results from experiments to determine which version of a product or feature performs better. Now, let's take a look at the last part, which is data platform monitoring. So, data platform monitoring is important for keeping track of health and performance of entire data stack. Its main purpose is to ensure that all systems involved in data processing, storage, and analysis are working properly. By monitoring everything, we can spot issues early, avoid downtime, and ensure that data is always available and accurate. So, why data platform monitoring is needed? Data platform monitoring tools are used for several important reasons. One is track system performance. These tools help track the performance of databases, data warehouses, and processing engines. If there are any slowdowns or inefficiencies, the system can notify the team so they can take action before it impacts users. Detect errors early. Monitoring can identify errors such as data ingestion failures, broken pipelines, or data quality issues. Fixing issues early prevents them from affecting downstream analysis and insights. Ensure data quality. It helps ensure that data being processed and stored is clean, accurate, and ready for analysis. Monitoring tools can catch issues like missing data, corrupt files, or errors in transformations. Maintain availability. It ensures that systems remain up and running. If something goes down, alerts are sent so the team can fix it quickly and prevent any disruptions to the business. And lastly, optimize costs. So, with proper monitoring as data engineers, we can see where resources are being overused or underused. This helps us optimize the data infrastructure, reducing unnecessary cost and improving efficiency. Now, let's understand this modern data stack with a simple example. Imagine the business needs hourly reports in a BI system showing these metrics like hour of the day, number of bookings, number of rides, number of cancelled rides, number of unique passengers, unique drivers, revenue in USD. Now, to solve this business problem, we have to go through a bunch of different steps to handle this business requirement. So, basically, we will have data ingestion pipelines. To meet this requirement, we can set up hourly data ingestion pipelines. And these pipelines will pull booking, passenger, and driver data from the booking system. Using tools like Spark, the raw data can be stored in the data lake at the silver layer in its original form. Next is data transformation pipelines. So, a data transformation pipeline can process the raw data from silver layer. It will calculate the required business metrics such as total bookings, revenue, based on the business rules. The transformed data is then stored in the gold layer, ready for analysis. Third step will be data mart creation. So we can use Athena, we can run aggregation query to read data from gold layer. This processed data is then stored in the data mart table, optimized for reporting. Fourth is data quality checks. While setting up these pipelines, data quality checks can be configured to ensure data is accurate and reliable. These checks monitor the health of the data at every stage. Pipeline scheduling. All these pipelines, data ingestion, data transformation, and data mart, can be scheduled in Airflow to run every hour. They will follow our dependency chain, ensuring each step runs in the correct order. BI system integration. So, data mart table is then used by the BI system to refresh hourly reports. These reports give the business real time insights they need. And platform, finally, the platform monitoring. So, the health of the data pipelines, data quality, data refresh status can all be tracked in one single place using data platform monitoring. So, with this setup, the business gets data up to date, hourly reports powered by a robust and well monitored modern data stack. So, with this setup, the business gets up to date hourly reports powered by a robust and well monitored modern data stack. Each step from ingestion to reporting works seamlessly to deliver accurate and timely insights. So, this brings us to the end of our session on modern data stack. I hope this gave you a clear understanding of how different components work together to create a seamless data ecosystem. Take some time to review the key concepts. Feel free to explore further on your own. If you have any questions, don't hesitate to ask. Thanks for joining today. I will see you in the next lecture.